Hi everyone, did you know that microprocessor is everything and everywhere? You can find it in your phone, televisions, cars, and many more. It also can provide intelligence in it. A microprocessor is an electronic component that is used by a computer to do its work. It is a central processing unit on a single integrated circuit chip containing millions of very small components including transistors, resistors, and diodes that work together. We're here to present to you about our mini project for subject microcontroller technology, which is customer limitation counter.
Project description. The project of microprocessor for our group is named Customer Limitation Counter. Customer Limitation Counter is a project that can prevent the spread of COVID-19 by practicing social distancing. This project will tell the customers either the shop has already reached its limitation or not. For instance, in this project, when customers stand in front of the shop's door, the sensor will detect their presence and green LED will light up if the shop has not yet reached 5 people. If the shop has reached the limitation of 5 people in it, the red LED will light up and a beep sound will be heard. This means that the customers encounter red LED and the beep sound has to wait for their turns outside. However, the limitation can be changed to even more or less than just 5 people in the shop if the shop has bigger or smaller spaces by changing the coding.
Problem statement. Difficult to monitor the number of customers entering the premise due to lack of employee. Employee can also be exposed to the public while guarding the interest of premise when pick up the temperature and check the number of customers. Last, the customer have to wait a long time to get their turn to entering the premise. Objective of this project: to design customer limitation counter system for premise application with the presence of infrared sensor, to simulate a customer limiting counter system by using Protospec software, and to carry out functional testing of the system.
Next, we will present to you about theoretical. In this part, we will explain each part of the component that we use to create this project and the importance of that part. The main component that we use in this project is Mbed LPC 1768. The Mbed microcontroller is an ARM processor, a comprehensive set of peripherals that has a USB programming and communication interface. LPC 1768 microcontroller is a brain for this project that used to control the circuit. This product is made by a company called NXP Semiconductors and contain an ARM M3 core. In this figure, you can see the main features labeled. USB connector is where the program is downloaded and can also power the Mbed. There are 5 LEDs that have on a board, which is one for status and the other 4 is connected to 4 microcontroller digital outputs, so it can allow a minimum system to be tested with no external component connections needed. A reset switch is to force restart of the current program. Next is LED. LED is light emitting diode and semiconductor light source. It produces light when electrical current flows through it. In this project, it gives signal to people to enter or wait for their turn in the store. Red is symbolizing danger in many cultures. It tells people to stop to prevent any danger. Green is symbolizing caution and tells people that all clear and safe. So, when the LED turns green, it means that only 5 people can allow to enter. Then, when the LED turns red, it gives signal to people to wait for their turn. With this signal, it can prevent COVID-19 from spreading from each other. Resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. They are used to set currents that through it and adjust the voltage levels when in series circuit. It can give feedback, pulling up or pulling down floating voltage, gain control and terminating loads. Resistor is important to limit the flow current. If the current overflow, the component like LED or sensor will damage and circuit will overload. Next component is buzzer. A buzzer is an audio signaling device. It is a small component that can add sound or alarm in project or system. Buzzer works as a reminder to remind that only 5 people can enter to the store. If the red LED lights on and someone enters the store, infrared sensor will detect the motion then trigger the buzzer. So it helps people to follow the standard operating procedure, which is SOP. Last component is infrared sensor. This component can measure and detect infrared radiation around it. By using this component, it can detect the motion of person who enter the store. Infrared sensor will automatically trigger when red LED is light on. Then, when it counts the object more than 5, the IR sensor will transfer the data to buzzer to make a beep sound so it can ease the seller to track the person who entered the store before the green LED lit.
Now, I will explain about the circuit design. This is the schematic circuit of our project. The VCC pin of infrared sensor is connected to V-in pin of LPC1768, while the out pin of infrared sensor is connected to pin P10 of LPC1768. Besides that, the red LED is connected with pin P22, while the green LED is connected with pin P23 of LPC1768. Lastly, the buzzer is connected to pin P24 of LPC1768. Next, I will explain the flowchart of our program. This is the flowchart of our program. The green LED will light up when the circuit turns on. Then the infrared sensor will detect whether there any person passing through the sensor or not. The current status of the infrared sensor will send to the microprocessor. The counter will increment by 1 when there is a person passing through the sensor. The counter will stop counting when the count has already reached 5%. When the counter reaches 5%, the red LED lights up and the buzzer make beep sound. This indicated the number of persons go into the store have reached the SOP limit. Then the program will delay for 10 minutes. After 10 minutes, the program is going to repeat again. Now, I will show you the coding simulation. This is the program of our project. Firstly, the infrared sensor, LEDs, and buzzer was initially setting by referring to the GPIO table. And then pencil 0 and pencil 4 was used to determine the function of each pin. FIO0 direction and FIO2 direction is used to determine whether we want to use the pin as input or output. Inside the start loop, the FIO2 direction will turn on the green LED, while the FIO2 clear will turn off the red LED and the buzzer. After that, the program will go to sensor loop. Inside the sensor loop, the current status of the sensor will be obtained from the FIO pin. And then, the current status of sensor will be checked by using an operation. If the result of the AND operation is equal to 1, the program will go to count loop. Count loop will be operated as a counter. The value inside register 8 will increment by 1 each time the sensor detects there is a person go into the store. If the value inside register 8 is less than 5, the program will go back to sensor. As you can see, the value inside the register 8 has increment by 1. When the value inside register 8 has reached 5, the program will go to limit loop. Inside the limit loop, FIO2 clear will turn off the green LED, while the FIO2 set will turn on the red LED and the buzzer. Then, the program will go to delay loop. Inside the delay loop, the program will delay for 10 minutes. After 10 minutes, the program will go to start loop and repeat the program again. That's all for our program simulation.
Let's discuss this project. This project is successfully done after multiple of problems encountered. The first time the codes was simulated, there is errors appear on the Kills programming software because the type instruction would not click. Then, it is solved by checking the program and run the codes for the second time. Next, counter loop was counted wrongly and the value to reset counted was left behind. After noticing the mistake made, the initial value of R8 was entered. On the third try, all the problems stated before is solved, but a new problem is faced, which is when the program finishes executed, it does not start from the beginning again because there is no start loop in the program. Finally, a start loop is entered on the last part of the program succeeds. There are several benefits that we can get from this project. For example, in this project, the buzzer will make a beep sound every time the shop has reached its limitation of people, so it will make it hard for customers to disobey the Standard Operating Procedure or SOP. Sometimes, though the limitation of people in the shop has been stated, customers could still be confused on how many people are already in the shop. This customer limitation counter device could help them know immediately. That's all for discussion.
The conclusion of this project is the SOP to prevent the spread of COVID-19 can be practiced and ensure that customers can follow the rule. Also, the function of this system is reliable and accurate. It's easy to handle by any person because this product is easy to understand and doesn't require energy. Last, it can speed up the movement so customers not be exposed in open place for a long time.